the second part of the hyperbola worksheet. We're going to do a couple things here. Some of the things we did yesterday is kind of identifying the parts of the ellipse, like the focus, the vertices, and a few others. But we're also going to go back in and review how to do completing the square. This is exactly the same completing the square as we did with the ellipse, and a lot like the one with the circle. So there shouldn't be a whole lot of surprise there. You can see so far, I've started looking at number 5. I went ahead and I've rearranged the equation to get it like this. I've got the y's together, I've got the x's together, I've gotten the positive squared term. One of them will be squared, right? One of the ways we know that this is a hyperbola is that when I look at the two squared terms, one's positive and one is negative, right? That is a dead ringer for any time you have a form like this, and it says, hey, what conic is it? It's really easy to determine if I just look at the two squared terms. If the signs are opposite, the numbers don't matter. If the signs are opposite, you're going to have a hyperbola when you're done with it. So what I'd like to do now is just kind of take you through the completing the square process and to get this into its standard form and then identify the parts. So the first thing we do is kind of get our setup ready. We're going to factor out the numbers right before the squared terms. So for y squared, we're going to factor out 16. So it's going to look like this. So 16 and y squared plus 4y. And at this point, I'm going to add some unknown value here. In the next part, we're going to factor out a negative 9, which leaves us behind x squared. Now be careful, because we factored out the negative, it's going to change the signs of everything inside. That's going to leave me with 6x, of course, plus something unknown, and then it's going to be equal to 593. Make sure that when you set this problem up, you take your constant, your whole number value, the one without a variable, and you're going to bring that to the other side. In this example, I had to add it to both sides. In other examples, I may subtract it, so be careful about your signs. Next step is to use b over 2 squared. I'm going to add that into those blanks, and then I'm going to multiply times the number up front before I add it to the opposite side. So we're going to start out with 16 y squared plus 4y. Now b over 2, obviously b in this example is my 4, and so I'm going to take 4 divided by 2, which is 2. I'm going to square that number, so 2 squared, right? So 4 over 2 squared is going to be 2 squared, which is 4. So we're going to add 4 here, but remember, when we have something outside of our parentheses, we have to take that value, we have to multiply times the value outside, which makes us have, so this will be equal to 593. And it's going to be plus 16 times 4, which is 64. All right? And then we're going to do the same thing again, but this time we're going to do negative 6 over 2 squared, which is going to be negative 3 squared, which is just 9. So we're going to have plus 9 here. But 9 times negative 9 means it's negative 81. That's right, negative 81, because we said 9 times the negative 9. And that makes us have a negative 81. At that point, what we're going to have to do is we're going to have to combine all of those values and simplify and factor, and we're almost done, in fact. So let's kind of bring that down. We're going to have 16, and remember, we factor this, it's y. It's going to have the same sign as this value here, and I'm going to be putting in the value right before I squared it. In this case, it's a positive 2. I'm going to put that in right here. So plus 2 squared minus the 9, right? These parts just kind of come down, and I'm going to say x. This is a negative 3. That's what right before I square the value right here. So I'm going to bring that value right down and add it, or in this case subtract it, inside my parentheses, squared. That's going to be equal to 593 plus 64 minus 81 gives us 576. Just like the ellipse, your very last step is to divide by whatever value you have on the other side. We want always to have that equal to 1. 576 here. And essentially what I'm going to do is I'm just going to divide 576 divided by 16, and that's going to give me the value that should go into that, right? 16 goes into 16 one time, and 16 goes into 576 36 times. So we're going to end up with y plus 2 squared over 36. This is going to be minus, we're going to do the same thing again. We're going to do 576 divided by 9. That's 9 goes into 9 once, 576, it goes 64 times. So we end up with x minus 3 squared over 64, and this is equal to 1. Right? And that takes us down to the proper form. This is our standard form. This allows us to find all the different pieces that we need in order to graph this. Although graphing is not the goal here, I'm going to list out the pieces that we can see. My center, that's going to be important for finding some of the parts. That center is 3, negative 2. Remember, the x part comes from the x term and the y part comes from the y term. I'm going to switch the signs every single time when I'm coming from the form, from the formula, into writing out the parts, right? And this part A is always the one up front. In the hyperbola, A's first, B's second. In the ellipse, they can switch. Okay, in the hyperbola, in this one, I can swap my top part, switch back and forth, right? Because we want to have the positive and out front, so we can switch these two pieces. Okay, so A. Really, I'm not focused on the A moving places, it's the top parts moving places. So in this case, A is 6, B is 8, and this is the Pythagorean theorem here, so I'm going to have C equal to 10, because we would do 36 plus 64, which is 100. That's equal to C squared, so obviously when I square root both sides, I get C equals 10. Now, when it comes to identifying the foci, the asymptotes, the length of the transverse axis, so transverse axis, and the conjugate axis. When it comes to finding these, there's a couple things that are really easy. Foci and the asymptotes. If you have the formula sheet, which I highly recommend you focus on, that's going to make this job so much easier. If you don't have it, then you're going to have to kind of figure out all the different elements that you're looking for. And that can be a bit challenging when you're trying to find all the different pieces. So what we're going to do here, I'm going to pull up my formula sheet. Find the bloody thing. Okay, here we go. I'm going to pull up my formula sheet, and I'm going to identify which axis I have. Because we are looking at the y first, we are looking at a vertical, right? So it's going to look like this, a vertical transverse axis. So that's going to bring in certain formulas. So I'm looking at my formula sheet, looking at the vertical transverse axis section, and I'm going to write down the formulas for all the different parts, right? And so we have to find the vertices, the foci, and all the rest, right? So here's the formulas. What we have is, for vertices, we have h, comma, k plus or minus a. For foci, we have h plus or minus h, and it's going to k plus or minus c. For your asymptotes, we have y equals k plus or minus a over b times x minus h. The transverse axis is always 2a long, and the conjugate axis is always 2b long. That's a definite, that's something I don't even have to worry about on which direction it's opening. The length of those things are always that way. Piece of cake. So let's just kind of fill out this piece. My vertices, I'm going to take my center. It's going to be h, which is 3. And a in this case was 6, right? So we have k, which is -2, plus or minus a, which is 6, right? So -2 plus 6 is 4. And then 3, -2 minus 6 is going to be -8. To do the same thing with my foci. This time I'm going to be adding -2 plus or minus c, which is 10. So I'm going to have 8 and 3, -12. Let's go ahead and do this piece. 2 times a is 12, and 2 times b is 16. If I write out my asymptotes, it's going to be y equals k, which is -2, plus and minus 6 over 8 times x minus h, which is 3. Now, I could leave it like that, but I can guarantee you that on a multiple choice situation, you are never going to see your asymptotes look like this. So we're going to need to simplify that and probably get it into 2 different forms. So y equals -2. I'm going to reduce that fraction. 2 goes into 6 3 times, and it goes into 8 4 times. X minus 3. So what I'm going to do is I'm going to distribute this and kind of see if I can collect some like terms. Right? So y equals -2. We'll do the plus first. 3/4 x minus 9/4. So I have 2 like terms. I have 2 and I have -9/4, actually -2. So I'm going to convert the 2 into fourths and bring them together. So y equals +3/4 x minus 9/4 minus 8/4. Because they're fourths, I can add them together. I've got common denominators, and so we can have y equals 3/4 x, and this is going to be minus 17/4. Right, so there's one asymptote. I'm kind of showing you every step. I'm kind of taking it a little bit extended explanation, so it doesn't always take this long. And this will be y equals -2 minus 3/4 x, and then I'm going to multiply through here, and this is a -3/4 times a -3, so you're going to get plus 9/4. So you can see the parallels between what I did before and what I'm doing now, right? So really the changes are the signs here. Since my value was negative, it just swapped these signs. And so I'm going to get something very similar to before, but the signs are going to be a little bit different. So if I complete this, we're going to get y equals -3/4 x. It's going to be plus 9/4 minus 8/4 to get a final asymptote of y equals -3/4 x plus 1/4. And that finishes it out. Now that was number 5. That was a lot. We had to do essentially 2 problems together. And so we found the vertices, check, foci, asymptotes, the length of the transverse, and conjugate axes. So step 1 was just to kind of get it into this form, then determine which formulas I'm going to need. This is vertical transverse axis. And then I just found each of the different pieces that it was asking for. Okay, now I'm not going to take the time to talk you through 6, 7, and 8. I'll do the work for you, and you can kind of watch and see how that plays out. Note that in every example, especially 6 and 7, the process is going to be exactly the same. And 8 is kind of an easier one. I don't have to complete the square for that one. I just have to identify the parts, but I'll do it in the same exact way as we did before. Got any questions, make sure to send me a message and ask.